Welcome to another Numpy video. In today's video we're gonna talk about reshaping, transposing, and getting unique values and counts, and also broadcasting. First of all, let's specify an array that is gonna be having dimensions of 2.4, meaning 2 rows and 4 columns. You can use the .reshape function to change the shape of the array. So you can specify that you want the rows to be 4 and the columns to be 2. And Numpy is going to be reshaping your array according to your needs. So here you can see that the first row was split into 2 rows of 2 elements, and the same happened for the second row that became actual 2 new rows. Then you can use the .transpose or .t to transpose the array. Check out the result. What we can see here is that the array, the original one at least, becomes transposed. So the rows would become columns and the columns would become rows. And you can see the result here. So 1.2.3.4 was a row and now it became a column, while 4.5.6.8 was another row and became a column. And we can see the result here and here. .t and .transpose actually do the same operation. Moving on to the unique values and counts, we specify an array A and we use numpy.unique to find the unique values of array A. And we can see that the unique values will be 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And what it does, it actually returns the set. Its value in the set is going to be unique. So we see in the original array we have 2 12s, but here we only have 1. We can also use numpy.unique and also specify the attribute return index equals true, and you can get a tuple of results. The first one will be the unique values and the second one will be the first index where this value was encountered in. So for example, 11 was on the index 0, 12 was on the index 2, 13 was first encountered at index 3. And you can also return the counts of occurrence for its unique value, which is really helpful. So you specify attribute return counts equals true, and boom, you can see the count for its unique value in the original array A. Moving on to broadcasting, if you have a matrix and a number or a vector or something else, Numpy can understand that the multiplication should happen with its cell. So if at least one of the dimensions is equal to 1 for either one of the two things you want to multiply, Numpy can understand and do cell-by-cell multiplication. If not even one dimension is compatible, it will throw a value error. So here, what Numpy does is that it broadcasts this array, this value, to each of the cells. So this is a 1.2 shaped array, and Numpy can actually do the multiplication by a number. And also here we can see 2 rows, and again it can multiply them because one of the dimension at least matches. So that's broadcasting.